Analyzers, and welcome to Chapter 2, Lesson 6 Notes. And we are talking about graphing quadratic functions. Yay! Parabolas. I love a good parabola, as we all know. Let me scooch this over here so that when I'm leaning in, I'm not completely out of the video. All right, well, here goes. So, let's talk about all these fun boxes on this fancy schmancy familiar picture of a parabola. So as we know, parabola is the other word that I use interchangeably with quadratic function when I'm describing a quadratic function or parabola on a graph, right? And of course, it's a U shape, either smiley face like this one is, or frowny face when it's upside down U. What we know of this particular parabola, because we've already kind of looked at it in vertex form and in standard form, right? We talked about that in the last lesson. So what we know about this particular one is that its vertex is at 1, -4. So I have that listed right here, right? So we know that its vertex, its axis of symmetry is x equals 1 because that's the straight up and down vertical line that touches the x-axis only at an x-intercept of 1. So that's why I know that this is x equals 1. Here, let me label that. X equals 1, vertex of 1, -4. So notice the value of the vertex, the x coordinate of the vertex is the same as the x value in the axis of symmetry, and that's because the vertex is always on the axis of symmetry. Right? We've done that. These are the roots or the zeros, right? The roots or the zeros. These are the x-intercepts, if you want to call them that. So, or roots, zeros, x-intercepts, any of those values, any of those terms talk about where does the parabola cross or touch the x-axis. And so that's your x-intercepts or your roots, okay? And then, of course, some reference the y-intercept. I typically don't, but it does have a good meaning. So this is my y-intercept. It does have a value in the standard form of the equation. In the standard form of the equation, this will be the number being subtracted right here. So that's going to be your y-intercept. Okay, and the reason for that is because this point is 0, -3. What's the x value of this point? 0. So if I plug 0 in here and here, all that's left is -3, and that's what y would equal. So that's how I know this is going to be this number at the back of that equation. Okay, so there's a few things that can come together there when that is the case. And again, I show you that right here with the y-intercept in this trash color box right here. Can't even say it without laughing anymore. You guys are taking purple as a trash color so seriously. I love it. I've really hit on a nerve. Oh, anyway, okay. So, knowing all these relationships and how these numbers are now fitting into then equating this thing on the graph, it's just helpful. But you don't have to know it all. You know, that's what the graphing calculator is for. I've got one right up on my screen over here. I've got one right here. You know, you can always plug this into y equals for your points to put on the graph. Okay, and so that's what I'm going to show you today. Do I know all this stuff? Sure. And do I use it to graph? Absolutely, because it really is faster than plugging it into my graphing calculator when you know it. But you always have this graphing calculator available to you, so you do not have to have these things memorized. Now, again, this is a good reference of all the things we've kind of already discussed about each of these pieces. For example, finding the axis of symmetry in standard form of your quadratic, you use x equals -b over 2a and plug those values in. Okay. X-intercepts are the zeros or the roots, right? If you have standard form of your quadratic equation, you factor that into two pieces, and those two pieces give you the values of your roots, the x values of your roots, okay? Because you're pretending that your y is 0. And so it's just like what I said here was I know that this is -3 because if I know that the x value of this has to be 0, then that's what I plug in for x, and that's how I get it. or here, I plug that in for X and that's how I get it. So because I know those relationships inside and out, it's so much easier for me to use that to graph. But you do not have to do that. Okay? What I'm telling you is you can use this graphing calculator to graph. All right? So I just want to show you this first. Okay? I want to show you how to do it on your graphing calculator. F of X equals, in parentheses, X plus 2, or excuse me, X plus 1 squared minus 4. So we're graphing the vertex form of the equation that we figured out back and forth the other day in the chapter 5 notes. Okay? It's the other day for me. It could be the same day for you. Who knows? I know all this information based on just looking at the two equations back and forth. Okay? I know that my vertex is -1, -4. I know that my axis of symmetry is X equals -1 because it's the opposite of the sign on the inside. So notice those X values are the same. I know that if I factor this, I get X plus 3 and X minus 1, which means my roots are -3 and 1. And then I know if I plug 0 in here for X, what I'm left with is this -3. So the y-intercept is -3. So since I can look at the two equations and know that information, I could graph those pieces and then the rest of the parabola behind it. You use this guy, press y equals, and plug the equation in. So I'm going to do this equation right here. X plus 1 in parentheses squared minus 4. Got it. Okay. Let's press graph to see it. Oh, prettiest parabola in the world. Yeah, maybe not the whole world, but pretty close. All right, I'm thinking we've got a vertex over here at -1, -4. Oh, that sounds familiar. Right? Got a axis of symmetry right here at X equals -1. So that's my straight up and down. We've got roots here at 1, -3. We've got a y-intercept here at -3. So you can see all those things. You can see them on the picture. Let's confirm them on the table. So second in graph gets me to my table of points. I want kind of an evenish table. So let me arrow up and down so that what I get looking on my table are points that I can graph. I can put on a 10 by 10 grid. So you kind of look, -5, 12 really isn't going to fit. All right, but I'll do my best. I'll show you where it would go, right? -4, 5. Okay, so here are, look, there's my vertex right in the middle there. And notice now my y values go back the other direction. Okay? So I'm going to copy that table right here onto my paper. And I'm going to start with the -5, 12, even though I don't see that really fitting super well. And all the way to 312, right? And so we kind of go, you'll see the pattern in the y's. So let's see, we've got 5, -4, 5, -3, 0, right? There's a root. Mark that. -2, -3, -1, -4. Okay, now 0, -3. Well, that's the y-intercept because the x value is 0, so that's the y-intercept. This, but I notice with my y's, this must have been the vertex, right? Which is also the x value of it is the axis of symmetry. So that's that middle. That's that middle. And then here, 0. Okay, that's my other root. So see those values that we had over here? That's where they all are. And then, of course, 2, 5. Okay, let's put those on the graph in this beautiful color known as aqua. That's right. I'm not using purple on a regular basis. Let's see. 1, 2, 3, 4. 1, 2, 3, 4, 5. And here we go. There's a root. -3, 0. 1, 2, 3. And then boom, vertex. Boom, y-intercept. Boom, other root. And a regular point. Sorry, no boom. I'll just do the points that actually fit on the graph. So -5, 12, and 3, 12. Sorry. It's 10 by 10 grid. What do you want from us? How about I indicate that those exist by putting arrows at the end? Now, I don't try to pull my parabola. See how I did that? I stopped at those points that fit on the graph, and that's where I put my arrows. Don't try to like pretend you know where this parabola is going, because if you extend this incorrectly, okay, I'm going to grab a pencil and do that. I'm going to grab a pencil, extend this incorrectly. Let's say I was like, I know it goes here, and I know it goes here. Well, that's wrong. So Mrs. Collins has to mark that wrong. Don't do that. Stop at the last point that actually fits on the graph and put your arrows. Okay, stop at the last point that actually fits on your graph and put your arrows. All right, label with equation. I don't care which one you use. I'm going to use the first one that I plugged into the graphing calculator. And there you have it. That's how you graph a parabola. All right, just so you know, right? Axis of symmetry. AOS, x equals -1. Okay, instead of writing out axis of symmetry every time, I abbreviate AOS, as you know. Vertex right there on the axis of symmetry, right? So there's your vertex. And what was that? -1. Well, yeah, because my axis of symmetry is x equals -1, so that has to be the case. And I think we were down to -4. Yep. Okay, roots. So right here, the zeros are the roots. Okay, these are -3, 0, and 1, 0. Here's your y-intercept right here. This guy is 0, -3. So there's those real important pieces, right? I'll put y int next to this one and r for roots next to this one and that one. And there you have it. Just do it off your graphing calculator. Just do it on your graphing calculator. Look at that. I almost anticipated that. It's great to graph knowing these relationships, but you always have a graphing calculator to help you. So use it. And that's what I plan to do. Thank you for warning me in advance, past Mrs. Collins. You're such a smart person. All right. So as I was talking to myself and complimenting myself, because obviously I'm the best. Here we go. Ooh, I'm so the best. Why do I have a double parenthesis there? That's no good. All right. Let's get this on our graph. It's going to be upside down, frowny face. We're also going to have a wider parabola because, or excuse me, a narrower parabola because we've got this 2 in the front. And then that's the y-intercept. Ooh, yikes. What's this going to look like? Oh, wait, did I put the right thing at the end? Oh, because I'm upside down. Oh, yeah, it must have changed the whole thing. Yeesh. Oh, duh. I was being dumb. I'm sorry. This is in vertex form. So this is -310. 310 is my vertex. So that's why it's up here. I wasn't thinking. So my y-intercept is, yeah, going to be down here. That makes more sense. I was thinking of the wrong form. My bad, guys. So this is why just use your graphing calculator. Then you don't have to worry about that stuff. Second in graph. Okay, I think this is enough right here. 0, -8, down to 6, -8. So that's enough points to put on here. Let's put them on our table. Always write down your table so we know where you're getting your points that you're graphing from. So if you graph like incredibly wrong, at least I can see that maybe you had the right points written down over here at some point. That's a lot of using the word point right there, wasn't it? Ooh, no rational roots. Ha ha ha. Interesting. I say that because there's no 0 y value. We go straight from 2 all the way down to -8, right? So the roots are in between here and here. So we're going to touch across the x-axis, not on actual integer points. Interesting. So not integer points. I can say that right now. Axis of symmetry, though, it's going to be right here. x equals 3. Whenever you write out the axis symmetry, it's always x equals because it's a line that cuts your parabola in half. The vertex is always a front parenthesis, the same value for x as the axis of symmetry, then comma, y value, end parenthesis. There you go. So that's going to be your vertex. And of course, the y-intercept is where your x value is 0. So that would be 0, -8. And let's just get these points up here. And we done. We just have to label 0, -8, 1, 2. Yeah, that's quite a jump. That's because this is just such a narrow parabola, if you will. But you won't. Because unlike that one year that I convinced an entire freshman class that it was parabola, you're not part of that. Here we go. Frowny face, very narrow, label. This is how we graph parabolas. Always label with the equation, guys. You're good. Got anything for me? Let me know. Otherwise, get to this 2-6 homework right after this, and we're all set with that. So, math analyzers, I'll be seeing you. Have a fantastic day.